In this lesson, I would like to talk about assets, because so far we've been playing with cables and the basic shapes, but we didn't really leverage the fact that we can import images, videos, audio files, or 3D assets inside of a scene. So I would like to just talk about this and see how we can do this together. So here I have a new project. It's a simple project as usual. We're going to put our main loop. And I would like to start with the simple image, right? This is something that that is very common in different cables project. So how would you import an image? Well, first we need to display the image, right? So I would suggest we maybe start to draw a rectangle. So I know I'm going to have a sequence there because we're going to show different IDs. So I'm going to create a small sequence. I'm going to create a simple rectangle. And now, if I want to change the color of the rectangle, we know that we always need a material. So I'm going to just use a basic material. And by default, it's just a plain color. But we see that on this material input, we have a texture. So texture, it's basically, an image that has been processed and put in the GPU memory. So it could be loaded from a JPEG file, a PNG file, and then basically decoded by the computer and put on the GPU memory. So let's talk about textures and let's see how we can create one. So there are two ways. Either you are in the material and you click here, will actually create for you the texture node and connect it automatically. Or we could have just put in the patch a texture up. Now, when you put the texture up, you see that nothing really happens because it asks for a file. So if I click here on none, it will actually open the file viewer. We can see it here. If you go on this tab button files, it's the same thing that happens. And notice that we have library files, which are files that are included by cables for all projects. And we have also patch files, things that we can drag and drop in the patch. So in our case here, we could start by just dropping an image. So I have this image here and I'm dropping this image in my patch. Now, because I've opened the file here, I can select it and you see that automatically on the right, it changed the name. But it's two things about this. First, if I click again, we actually now see that instead of being just a really regular button, we start to see that this is actually a URL file. Everything that we put in a cables project is necessarily any asset is stored on the server. Because imagine that now you want to deploy your project, all the clients, so meaning all the people in there with their own browsers, need to download the image again. So nothing is really stored on your computer. I'm dropping this file, it goes on the cable server, and this is now the URL of my image, which is /assets because it starts with the, this is like, before that it's the part of the cables website, and then in asset, then this is the ID, the full identifier of my patch, and then the name of my file. So when you are actually loading a texture, you are already making a network request to load the image. And this is really important. Why? Because if you have big images, like this one here, you are basically, if I click on the image, I have the pen here, and I know that this image is really big in terms of size, not really in terms of, size. Not the dimensions, but the weight of this image. So it's 1.72 megabytes, which is really big for something of this size on the web. Because even if you have like the fastest patch in the world, you would need to download some JavaScript code to actually make cables run. And then on top of that, now you need to load this as an asset. So 1.72 megabyte. It doesn't seem like much, but this is only one image. Now imagine you have 10 images. Then you complain because your patch becomes very slow to load. And if people have a slow website, they tend to close it. So we have to be careful that when we upload assets, they have to be optimized for the web. Fortunately, Cables is smart enough that it gives you some options here. So for instance, this is a PNG file, and I can convert it to a JPEG file, which will already be smaller because there's a better compression. But of course, there's a format that was invented for the web, which is called WebP. And if I click here, it will basically convert my image to WebP. And now check the old size, 1.7 megabyte, and now it's 0.1 megabyte or 128 kilobytes. So we like divided the size by 13, right? Or something like this. So, and it's visually, you will not see the difference. So now if I go and I click this instead, notice that this changed and I've selected the WebP version of the image. So already here we have divided by more than 10 the size of one asset, which is good because we want to have the smallest footprint as possible. All right, so something weird, if I go back to my texture here, and I see that this is actually, the ratio is, I think it's 16, it's a 16:9 ratio. And here also rectangle is actually square. So it would be nice to have a way to automate so that we are basically independent of the size of the texture, and we always make sure that our rectangle, which we use here to display the image, matches the resolution. So how could we do this? Well, it's pretty simple. The texture itself gives the size and the aspect ratio here directly. You can also, if I just take the output of my texture here, aspect ratio, and I just multiply the width, then now the rectangle matches the size of my texture. And if I change my texture and I put a square texture, then the rectangle will match perfectly. Let me put an orbit control so we can zoom in a bit. All right. And yeah, we are a bit far, but I can make a transform view, as we know, to zoom in if we need to. All right, and this is my image. Okay, so I hope this is an important one. This is just loading one texture. Now, what if you have a bunch of textures, other images? So let me try. I'm gonna upload one other image and transform it again using the same technique, converting to WebP, and the third one, just for the sake of completion, up. Okay, so now I have 3 images. And I would like to maybe have a way to swap the background, right? So there is a knob in Cables that is called switch texture, which is basically a bit like, you see we have switch object, switch array, so it's always the same concept, but here we're gonna use it for textures. And what it says, it's you need basically a number, and it will output. So let me try to put this before the material. And now I'm connecting my texture to the first input. And I want to load several images, so I can do simply copy and paste. But there's another way, because imagine you have 10 texture. I don't want to copy and paste the 10 ops, right? We know better than this. But just to demonstrate with 2 textures, I'm gonna take the second one, connect it here, and now depending on the switch, basically I can say, hey, depending on the input here, it's either you take the first one or the second one. So because it's computer, 0 is the first and 1 is the second. And both textures here are, they have the same ratio. So instead of going back and say which aspect ratio we choose, we can also inspect the final texture that is coming out of the switch texture with something called texture info, which will basically repeat what we have here. And I can always get the ratio here and then connect it back to my width. So that irrelevant of the size of the texture here, I switch and then I always get the right aspect ratio, and then I scale my rectangle. Right, so I hope that this is clear. Of course, now we can use, for instance, a slider, or we can use something in the sidebar now to swap the background. So let's build this quickly with the small sidebar. So I have my sidebar, and I want to create, instead of making a slider, because this we already saw the slider, let me try to do this with the button, and then another technique. I have this button, and we're going to call it swap background, maybe. Okay. When I trigger this button, I want to alternate, switch and go between the first and second texture. So there is an op called increment, which is a simple op. Increment, sorry, up. Incrementor, yes, this one, incrementor. And this op is quite simple. You have two buttons. You can either count or increment or decrement. The length, which is until which number. So if I'm here and let me visualize the output of this number. If I click by hand, I'm counting, and when I reach 10, I'm saying, okay, I'm limiting, and I'm rewinding back to 0. So if I know that I have two files, and I can just, count 1 2 1 2 or 1 0 1 0, sorry, and now get this this number here and connect it to my switch texture, for instance. So if I swap the background now, I'm basically always going between 1 0 and 1, so that my two different textures. So this is another technique. And I like this op because it goes back to 0, so that so if you know how many objects you have, it's fairly handy. Now, as I said before, there's another way. If you have many images and you don't want to repeat the texture, you can use another op called texture array loader. And this works a bit differently, but you'll see what I mean. So here you would basically ask for a URL, but instead of putting the actual URL of one file, you would create what we call a mask, like a wildcard mask, and say everything that looks like, let's say in my case here, they are called background 1 and background 2 and background 3. So I would say everything that it starts with BCK and then I put an X after, then automatically this op will replace the X by a number. 1, 2, depending on the index start and end. So let me demonstrate. First, I need to get the path of my first image. So I go click on my texture, and now I know that, okay, the path starts, this is the asset and my patch ID. And now I have the path. I don't know why it's PNG. It should not be PNG. It should be the WebP version, okay? I'm here, I'm pasting the URL, and as I said before, instead of writing background 1, 2, and 3, I can say background X. Okay, so I'm saying, okay, background X, and I know that I have 3 values, so between starts at index 1 and it starts at indexed 3. So the X that I wrote here will be replaced by 1, 2, and 3. Let me try to see if it works. So this is, it's not the path to one file, it's a mask or a wildcard mask, and it was going to be replaced. Now I expect this to have different textures. So let me save and reload just to be sure, because I think it's better to reload to make sure that we don't load any extra fake texture. Here it's between 1 and 3, and I should have an array of 3 values. So now technically I have here 3, but you cannot really visualize them, but I have loaded my 3 textures in an array. So now I can simply do something like array get texture, specify an index, and get my texture back that I had before. So I can say now here I'm connected to the 3rd input. And now if I click to the swap background again, and notice that I will go back to the first one. But here, if I put array index 2, I will actually get the 3rd texture, And now if I swipe the background, I should have the right texture. Yeah, because I need to go here, 2, 3, equal, because this incrementer was limited to 2. So now I can really jump between 0, 1, and 2. And here I'm getting the third texture of my array. But this is actually 3 textures. So it depends on what you want to do. Either you want to switch the textures, or you use the incrementer to get the texture from the array and then put it into material. It's really equivalent. To demonstrate, I'm removing this, disconnecting it, only using my texture array loader, taking the increment, taking the output, put it there and in the material, and now it's the same technique, right? So I'll just show you 2 different ways. The switch texture, you really need to put different assets. If it makes more sense to have some kind of similar pattern, here you could use the texture array loader. All right, so this part was dedicated to images. Now let's talk about a small video, for instance. So if I want to load a video, it's really similar to what we have before. Fortunately, Cables have as in their basic files a video that we can play with. I would strongly advise not to use this though. I mean, to use it for very small videos, not big files, because it doesn't make sense. Once again, if you imagine that we try to reduce the size of our images to be very fast when we load the patch, then we're gonna load like a very big MP4 file. So if you want to stream video, it could be another lesson. It's usually you would rely on other services such as YouTube or Vimeo to host the video for you. It's actually quite complex to do a good job at streaming large files like this. So here it's something very small that you could use maybe for animated background. So it should be a small video and not a 3-hour movie, right? So really be careful about this. Notice that this op was created automatically. I was just taking the file and I dropped it in the patch. So it created the op for us, but we could have also, of course, put it ourselves. This is called a video texture, and it's exactly the same ID. Well, you have the file here. When I click on the file, it gives me the path to an asset that I load. It's either this is a Cables asset, so it would be asset library videos, but it could be asset, the ID of our patch, and just clouds.mp4 if we wanted to, and would be something loaded from the patch itself. And note that the patch files are actually shared on all your user account. So it means that in one patch you could start to upload assets and you don't need to re-upload them in the next patch. As long as you have the path, like here, assets, the patch ID, and the name of the file, this could be reused in any other of your other patches. And if it's the patch it's public, then it can be loaded from there, right? So you don't need to re-upload the content many times. And you can always check what you uploaded. If you go here on your Cables page, you go to your My Data, and you see here you have patch storage, asset storage. So you know, like all the files that you have uploaded, where are they, and where they are being used, and so forth. So all your ops, when we code your own ops, it will be there. And so there's a neat way now to basically see what you have and what it takes on the Cables server. All right, so going back to our video texture, it's a bit of the same thing to be played. So it would have a path, a trigger here, which is basically the update function. This is important because the video by default plays in the HTML. It's an HTML element, which is captured by Cables at a certain frame rate, which basically comes from the update method. So it's like taking a screenshot of a running video and then converting this to a Cables texture and then outputting the texture. So this is exactly how the op works. So you can decide to connect this to a sequence, connect it to the main loop if you want to have the full the full speed, but you can decide also to only sample the video once every 10 frames, right? It's really up to you. So in our case here, I'm going to connect the video here. So it's being triggered a lot of times, but here I said, hey, the FPS of my video is 30. This I know from the video that I've uploaded. So this is by default. I don't know what the clouds.mp4 are, but it's usually 30 or 25 frames per second. Now I'm gonna connect this here and now connect to my material instead. And here I have the trigger, the play and pause trigger, right? So this I can also decide to connect to my sidebar, for instance. So I would be able to control it there as well. So simple, I'm gonna copy and paste my button. I'm gonna call this play and pause. Connect my button below, okay? And now I know that this is being triggered. So what I can do is just, it's something that it's either playing or pausing, right? So I can say, hey, I'm going to toggle a Boolean. And so it starts by being false, which is good. So it's not playing. And if I click, plays, right? Then you can decide to loop or not, to mute, and to rewind if you want to. For instance, if you have a big video, it makes sense to rewind. You can also speed it up. I want to read the video faster or slower, etc. So this is okay. And if we combine this with our switch texture, we could have either, if we wanted to, the video or the image, right? It's really it's the same thing. It doesn't matter that now the frame comes from a video, because in the end, it's just a texture, right? And from this texture info, if you want this to match also the right size, then we need to take the texture info from the video texture or from the output of a switch texture, and then to make sure that we are really respecting the ratio of the video, right? And if I swap my background, nothing happens anymore because we are pulling from the array get texture, but it's useless. We don't use it anymore, right? So you can combine the two if you want. So yeah, this is all there is to the video texture. It's very simple if you think about it, but really be careful with the files here and don't put something there that would be too big to load. Next, we have the 3D assets. So there is a lot of things to say. Like there are a lot of things to say about 3D assets. And fortunately, the Cables YouTube channel also covers this quite deeply. So I'm not gonna copy paste their video. I'm just gonna quickly show you that we can import other types of content instead of just images and video. And the one that I want to show here is it's called GLTF file, which is basically open standard to describe a 3D scene, and it's mostly used for web stuff. So that because you have many non-standard formats in the industry, and they try to come up with a standard, yet another one to be able to exchange files. So a GLTF file, think of it as just a big JSON file that describes what should be viewed in your scene, like what are the different nodes or objects in your scene, where do they load their textures from, what are the names, and how even the camera and of animation, everything described into one big file. And Cables supports this natively. The best way to have something that works is to export it from Blender and or download some kind of valid 3D assets from the web, which is exactly what I did here. So I'm gonna take this file, drop it here, which is so it's called, it doesn't have a real name, you'll see it's a smaller character. It's a GLTF file, GLB for GLTF binary, but it's just the same thing. And I'm also uploading the texture, which is within this model here comes from in another texture file. So see, it looks a bit weird. And to create the node to read this, I can automatically use this node from Cables, the cool helper, and you see that they will create this GLTF scene, which is created from this big file. And it's very simple. We need to connect it to render it. So I can now put my sequence, render it. And the first thing you need to take care of is like the size, because depending on the software you use, it could be very big, very small. So we need to play a bit. So you see, this is the shape of my character, but it's so big that the video is actually inside. So what I can do here is so you have this rescale button, and I can dial it down. I can also put a transform before and scale it, right? So I have the, and what I'm gonna do to move the character so it doesn't intersect with the background here. Transform, and I'm gonna push it, a bit forward like this. So we have our background and our character. And as you noticed, it looks like a character, but we have no texture. So we don't really see anything yet. But this is where the GLTF materials come from, and very handy. But so here, this is the whole scene, and it's a bit like a JSON file. So when you can actually use the same kind of viewer to inspect what is happening here. So let me push this aside a bit. Yes. And you have this button here, show structure, and tells you, okay, in my JSON file, which describes the scene, I have one material that is assigned to my octopus, and I have one mesh. So my scene here is very simple. It's just one mesh and one material. But as you can see here, you could have many images, several animation, different cameras, all included in the same scene. I can decide to only pull one node out if I want from the scene, transform it. And this is really well covered by the Cables video. So I'm going quickly about this. What is interesting here is the assign material. I know that I need to assign something to my octopus. So if I click assign, it will actually automatically create the node for me. I could have, of course, dropped it if I wanted to. And this is very simple. It tells you, okay, this is the material that I need to put for my scene. So I know that my material, as you saw before, was actually one of the textures. So if I go back to my texture and I load it here, now I've replaced the background with this texture, and I need before to actually connect. This is a texture, but what it needs as input is a shader. It's not just a texture. So it's something that is being run by the GPU, and you can actually have some kind of effects on top of it. So in our case here, we know how to create a shader. It's just basically a basic material. If you look at all materials, they output a shader. So if you are curious, you can just drop this and actually see what it looks like. So like it's defined, and you have another node called shader info. Shader, I think you can print the shader somewhere. Shader print. Shader define, shader info. And yeah, you could see all the shaders that are being created, and it will open this. This we can cover in the. I don't want to be sidetracked too much. So let's just think of this, and you can actually see the GPU code that is created out of your texture, how it's loaded, and so forth. Let's not go too deep about this here. This is an introduction to Cables, not an advanced class. But so right, there are options. What we need here is to transform this texture into our shader here. So the way we can do this is to simply put a basic material, for instance. So I'm gonna put this here. And I don't want to color the whole scene, so I'm gonna create another branch, one for the drawing the scene, one simply to convert my texture to a shader, and I connect my shader to my sphere, to my scene. And we know that something doesn't really look right. So we have to play, right? It depends on how the texture is mapped. So we need to play with it. So do we need to flip it? Yeah, it's not this. Do we need here to rotate the scene to make sure that it's loaded correctly? So that's the something you need to do every time you have something that comes from the web. I think it's okay, but it's rotated in the wrong way. If I turn it, you see my eyes are the other. So I just need to actually transform it. So I can go here and rotate around the Y axis and put 180 degree. And here I have my character that I loaded from the web. But be careful when you have the texture, you can really play with this because sometimes you have to flip it or yeah. But in our case, it was just facing the wrong way. So I just transformed our scene. And you see that this model that I downloaded from the web is not actually perfect. There's some kind of a seam here or you see through. But it will do, I think, for now. So this is our character. And you notice that, okay, it is loaded from the scene. If I put another material, for instance, remember the Lambert material, it will actually render the texture a bit differently with the kind of shadows, right? So I could use that instead. Just for you to see, like, it doesn't look the same depending on how you play with the material, right? And this doesn't matter because we used just being replaced by the texture. But you see, depending on the material, it's really doing its job and like showing that it could be this more metal, I would say, than the basic material, which is really plain. I think the basic material would be better but it doesn't really matter. There are other types of material that I will cover in the next lesson. So don't worry, I'll show you others. Just for the sake of the demonstration here, we can use this one. And we already have loaded a video, an image, and now a 3D scene. So the last thing we will need to do to conclude this session is to load maybe an audio track so that you have all types of assets that we can load from Cables. And to do this, it's really simple. It's the same workflow. We just simply drag and drop things. So I made a small song for this. So I'm not a DJ, right? But bear with me. We saw the last lesson that we could use the microphone and we needed this kind of play button. So it's kind of the same setup. If you want to play some audio file, you need to make sure that the user, has given you permission to do this. So once again, we can also play the play pause. We could use that to, I think, map the two things. So, okay, I'm gonna use the button. That the same input here. Oh, sorry. Play button. Okay, now what I need is to have two things. If I want to load the track, I need something called an audio buffer, which is basically a way to hold a sample that I can play with. And so first I'm going to drag my song. You notice that if I click on my song, it will create for me the audio buffer, right? I just wanted to show you it's the usual way. You can, if you know the node, you can drop it. You don't need to go through the UI. Now I have this buffer. It tells you, okay, you need something to play. The sample player doesn't exist anymore. It's the audio buffer player. Okay, so this is the way to play something. So here by default, we can start loop. So we're gonna make it loop. It's a bit like the video texture, right? You can restart it. You can have some offset and play and pause. But if you want to have some sound, you need an output, right? To actually acquire the output driver so that you can play the music. For now, I'm gonna mute it, but then I need to connect the sound. And okay, now we have this, play, pause, and I would like to do something with the sound. So what I suggest we could try is to make the character here react to the bass, really like a DJ, something that we could do in a party. You have some bass, and depending on how strong the bass or the rhythm of the bass, you would actually modify the size, for instance, of our character, right? It is one idea. I'm sure you have much better ideas in your own projects, but let's start with this. How could we do this? We have this node that we saw. It's called the audio analyzer, and we used it before to use the volume, like the average volume of the track, right? So here I could do the same thing, but if I want to be precise and only play with the bass, not play with all the other elements of our track, I would need a way to filter so that I only use the bass, right? So the way to do this is to, so first I need to connect, my audio sample here. And you notice that it also goes back here. It's a bit like the yellow cable chain. So I can do this, directly connect to the analyzer and then getting back to my output. So it's a bit neater like this. And what I have here in my output is the FFT array, which stands for the fast Fourier transform, which transforms the waveform into frequencies. Basically, it tells you which frequencies are being played in your sample over time. I'm going very quickly. Sorry if you know more about this. We don't have time to cover the whole FFT. I really invite you to look up on different media, such as YouTube. There's a lot of cool explanations about this. Just notice that we have this FFT, and it gives me 128 coefficients. So basically bands of frequency. So between 20 hertz and 20,000 hertz. This is like the human range. And if I take the first coefficient, they will give me the bass. If I take the coefficients at the highest coefficient, it will give me the high frequencies. Here we are really interested in playing with one of the first frequencies, right? The bass thing, because we want to make the character bounce with the bass. So we could say, okay, I only want a few frequency, and we know that we can use this array chunk to really cut my array here to take, I don't know, maybe the 5 first bands of my FFT here. And now what I could do is say, okay, I'm gonna average them. So to average, we have an op called info array, which is pretty handy because it gives you the min, maximum, and the average already from the array. So the array of 5 value goes here. Here I'm gonna average it. And then, as usual, we will basically map range the output and then use that with the transform to scale our scene. So if I'm here, I put this down. This I'm gonna put down also more. Saving my patch. Try to reorganize this a bit neatly. So I'm here. I know that if I scale this guy here, you see it will move. So I have this array here, and I can just simply map range it. I know that the minimum size could be, I don't know. So we don't really know the range yet, so we have to play a bit with the track to see what are we going to put into min and max. If it's normally between 0 and 1, I think, but I'm not sure yet. So I think it's normalized between 0 and 255, so it's 8-bit output. So if I go here, I can put 0 to 255, and I know my new min is going to be between 0.1 and 1.5, for instance. And then I'm going to connect this to the scale. So by default, there is no sound, and it's very small. Now, if I play, nothing happens. And so we have to check why it's not working, because first, of course, we didn't connect our play button. So I click here, so then it's being connected to the rewind button, and play. And notice now my character is actually, if I play here, so it's not stopping, right? I need to, for now, start and stop by hand. So the way to do this, as we know, is that we have this button that's toggled as doing true or false. So I can simply connect it here or create a variable as we saw before, right? So to make it a bit neater, but I think this is okay for the sake of demonstration. So if I stop, okay, if I play, now it plays, all good. Now notice that the movement, and we're gonna listen to the track, right? But it's very jittery. So as we saw before, we could use also a smooth op to try to make sure that it's not too abrupt, the changes, right? So I can put my smooth op. So first I will go to map range, I will go into my smooth, and now take the output of my smooth op and put it back into my scale, for instance. So it's actually much better. If I'm not happy, I can put more like smoother factor like this. And now notice that my character moves quite slowly, but still, I mean, we'll see if it matches the base. So now let me try to show you now with the sound. All right, so I hope that it worked, that you could hear the track. And yeah, with this, I think it will conclude our first view of the assets. I think we have every tool we need to create our projects. We have the sound, we have images, we have videos, we have 3D assets. In the next lesson, we'll talk about APIs and how we can load data, not that we upload manually to Cables, but that we can load from the web. I'll see you there.